Right now, there's a guy sitting in a freezing tent in the Australian wilderness.
Oh, wow.
Yeah, and he is bouncing his voice off the Earth's atmosphere, completely bypassing the internet, cell towers, the entire corporate tech grid. And today we actually have the exact data showing how he's doing it and, who is listening to him on the other side of the planet. So, welcome to today's deep dive.
It's great to be here for this one.
It is Wednesday, March 18th, 2026, and we are unpacking a massive real-time data dump for you today.
It really is a phenomenal data set to dig into. I mean, we are looking at a comprehensive guide and live telemetry from HamDash.
Right, specifically the newly rebuilt version 2.0.
Exactly. And for those who don't know, this is a free, open community amateur Radio Shack dashboard. It was built by an operator named Peter. His call sign is G0LLIW.
G0LIW, right.
Yeah.
And our mission for you today is to explore how this single browser-based tool aggregates what are, frankly, the seemingly magical elements of radio communication.
Because it really does look like magic if you don't know the mechanics behind it.
Exactly, because if you're casually listening to this deep dive and you think ham radio is just, I don't know, a nostalgic hobby.
Like people in dusty basements tapping out Morse code.
Yeah, exactly. If you think it's that, this dashboard proves that stereotype completely wrong. I mean, we are talking about a thriving, highly technical global network here.
Oh, absolutely. We're looking at live satellite tracking, monitoring solar flares, and real-time geographical mapping of people hiking remote mountains. It's wild.
It is. And the sheer volume of telemetry this dashboard handles in real time is, well, it's what makes it such a fascinating case study in modern communication.
It takes the absolute chaos of nature and human geography and just organizes into something actionable.
But, before we can even look at the wild data this dashboard tracks, we need to understand how you, as a user, actually access it.
Right, the architecture.
Yeah, because HamDash is built as this complete rebellion against modern data harvesting tech applications. It completely breaks the Silicon Valley mold.
It really does. That philosophy of privacy-first design is incredibly rare for a web application today. I mean, when you load up HamDash 2.0, there are absolutely no accounts.
Zero.
No passwords, no login with Google buttons silently scraping your profile in the background. You simply enter a call sign, like W1AW or a shortwave listener number.
And that's it. You're in. Your call sign, along with all your customized dashboard layouts, filters, preferences, all of it is stored entirely in your own browser's local storage.
Not on Peter's servers.
Right. Not in some cloud database waiting to be breached. It's all local.
And that local-first approach extends to your physical location, too, which is obviously crucial for radio operations.
Because you need to know where you are to aim your antenna, right?
Exactly. But instead of pinging your exact pinpoint GPS coordinates to a central database somewhere, the app takes your location and calculates a Maidenhead grid square.
Okay, what is that exactly?
It's essentially a grid system used by radio operators.
Yeah.
The app calculates it entirely locally on your device. It represents roughly a 9-square-mile area.
Oh, okay. That 9-square-mile buffer is kind of the genius of it.
It really is. You keep your operational precision for calculating distances and beam headings for your antenna, but your precise location.
Like your actual street address.
Right. Or the exact ridge you are hiking on. It never leaves your phone or laptop.
It guarantees operational security while still giving you the functional math you need for the hobby. And technically, version 2.0 pulls all of this off using what the developer documentation calls a single endpoint aggregate architecture.
Yes, let's unpack the mechanics of that, because it solves a huge problem for radio operators.
I was hoping you'd say that. How does it work?
Well, normally, if you have a dashboard pulling NOAA weather, DX clusters, solar flux data, satellite telemetry, your browser is firing off dozens of independent API requests every minute.
All these different servers all over the world.
Exactly. And modern internet service providers hate that.
Oh, they do. Security algorithms like Xfinity Advanced Security, for example, they see that rapid-fire outbound traffic from your browser to all these different global IP addresses, and they immediately flag it as a botnet or malware.
Right. And they just block your connection entirely. You're just trying to check the weather, and boom, you're shut down.
It's like, okay, think of it like this. It's like instead of you personally driving to 50 different stores to check prices, which makes neighborhood security think you're casing the joint.
That's a great analogy.
HamDash acts as a personal assistant who grabs everything in one trip and hands you a single, organized box.
And that server-side caching is an elegant solution. HamDash grabs all that massive amount of data on the back end, packages it, and delivers it to your browser in one optimized request.
So it's super fast.
Incredibly fast. And it uses very low bandwidth, which is vital if you are, say, operating on a spotty cellular tether out in the woods.
Yeah.
Of course, it keeps the aggressive ISPs perfectly happy.
Okay, hold on, though. I have to play skeptic for a second here.
Go for it.
The documentation claims it's not tracking you, right? And your data stays entirely local. But looking at the live data dump for today, the dashboard confidently states there are exactly 3,474 HamDash users online right now.
That's a very specific number.
Exactly. How can it possibly know that exact number without a central server tracking IP addresses or session tokens? I mean, something has to be tracking something.
It is a very clever workaround, actually. It leverages the public nature of the airwaves.
What do you mean?
Well, the user counter simply registers your active call sign in a temporary public pool because amateur radio call signs are already a matter of public record.
Oh, right, because you have a government license.
Exactly. Anyone can look them up via the FCC database in the US or the Ofcom database in the UK. So pooling them temporarily maintains your privacy.
Because it's public info anyway.
Right. The system isn't tracking your IP address or your behavior on the site. It's just tallying a public license that happens to be active on the dashboard at that exact moment. It fosters a global community without sacrificing personal security.
Okay, so it's just taking attendance of public identities. That makes total sense. All right, so once you are securely operating within the dashboard, the first thing you have to look at isn't the radio at all.
Yeah, it's not.
It's outer space. Because you cannot understand radio propagation without understanding the sun.
The two are deeply intrinsically linked. I mean, as any operator knows, bouncing high-frequency signals off the Earth's ionosphere is entirely at the mercy of space weather.
And what HamDash does is pull live telemetry straight from NOAA and NASA's Solar Dynamics Observatory. So it's putting the literal state of the atmosphere right next to your radio dials.
It's brilliant.
I'm looking at today's data dump, and I see all these solar stats. As someone analyzing this telemetry, what are the first numbers jumping out to you for March 18th?
Well, the primary indicators are looking fantastic today. We have a solar flux index, or SFI, of 113.
Okay.
We have a sunspot number of 83.
Okay.
And most importantly, we are sitting at a K-index of 0.
Wait, a K-index of 0, so the geomagnetic field is as quiet as it gets.
Exactly. It's a perfectly still mirror.
That's a great way to put it.
Because when the K-index is high, say a 5 or a 6, solar winds are just battering the atmosphere. Signals get absorbed, scattered, or they just get lost in the noise.
Right.
But a K-index of 0 means the planetary mirror is polished and stable. It allows a person sitting in their garage, running maybe 100 watts on a simple wire antenna, to bounce a signal all the way to Antarctica.
That is wild. But, you know, the sun isn't totally asleep today. The recent solar flare timeline on the dashboard shows a flurry of C-class and B-class flares.
There's some activity.
In fact, there was a B 3.0 X-ray class flare just peaking recently. Does that ruin the perfect mirror we were just talking about?
Not necessarily, and this is where the dashboard's aggregation really shines. It constantly monitors D-layer absorption alongside those flare reports.
The D-layer.
Right, because we all know how finicky the D-layer can be during a solar event.
Yeah.
Acts like a thick sponge, absorbing our HF signals instead of letting them pass through to the higher refractive layers.
So it just eats the signal.
Basically, yeah. But today, despite that B 3.0 flare, the dashboard shows D-layer absorption is holding at normal background levels.
Which means the high-frequency bands are operating nicely. And we can actually see the proof of that in the live DX cluster spots, right?
Oh, absolutely.
Looking at the data right now, the 40-meter and 80-meter bands are listed as hot, with 66 and 44 active spots, respectively. Meanwhile, the 12-meter band is completely dead.
And this highlights one of the most useful features for operators who might be overwhelmed by all that raw telemetry. HamDash includes an AI propagation synopsis tool.
Because all these numbers can be a lot for a beginner.
Exactly. It takes the SFI, the K-index, the D-layer absorption rates, and it translates them into plain English recommendations.
That's super helpful.
It processes the physics and essentially tells you, hey, based on current solar radiation, prioritize 40 meters for the next few hours.
So HamDash proves the planetary mirror is perfectly still today, but, I mean, a mirror is totally useless without a reflection. Who is actually out there bouncing signals right now? Because space weather sets the stage, but the true magic lies in the actors.
The human network is definitely where this data comes alive.
There is a tool integrated into HamDash called Where Am I Heard that pulls data from PS Reporter. You just type in call sign, and it shows you a map of exactly where that operator's digital signals are landing globally at that very second.
It's incredible. You are literally watching invisible radio waves blanket the Earth in real time.
Yeah.
It takes the abstract concept of propagation and maps it geographically. You can visually confirm if your signal path to Japan is open before you even start calling.
And the dashboard actively tracks de-expeditions. For anyone listening who isn't familiar, these are operators who spend thousands of dollars to travel to incredibly remote, often uninhabited locations just to set up a radio station.
It's a huge commitment.
It is. And they do this so other operators around the world can make contact with that rare geographic entity. Right now, the dashboard shows operators under the call sign CY0S are sitting on Sable Island.
Which is just this tiny sandbar in the North Atlantic.
Exactly. And they are operating on 40-meter Morse code right now.
The logistics of a de-expedition like that are immense. I mean, when we look at the dashboard showing the S-21WD team is currently en route to Bangladesh, updating the community that all their luggage is checked in.
Yeah, I saw that.
It's not just a casual travel update. These operators are coordinating the transport of massive generators, heavy Yagi antennas, specialized transceivers, and miles of coax cable across international borders.
It's a massive, massive undertaking. And it's not just remote ocean islands either.
No, not at all.
The POTA parks on the air and SOTA summits on the air trackers show real-time spots of people operating out in the wild. We've got an operator currently calling CQ, which means they are broadcasting to see who is listening from the Preston National Wild and Scenic River in Australia.
Right, the guy in the tent we mentioned earlier.
Exactly. And another is physically setting up their gear on a mountain summit, reference VK3 VS054. Plus, the dashboard is actively tracking 97 amateur satellites, including the International Space Station and Green Key B.
While also cataloging 537 active shortwave broadcast stations worldwide.
The scale of the data is just staggering when you lay it all out like that.
It really is. It's a lot of information.
But, this raises a major question about user experience, because if I'm an operator looking at this, it sounds like a giant real-time multiplayer video game map.
It does feel like that sometimes.
The players are real people standing on actual mountains and islands. Satellites are moving at 17,500 miles per hour, which is why the dashboard refreshes every 45 seconds. Doesn't this completely overwhelm the user?
It's a valid concern.
Do you just sit there paralyzed staring at a screen of flashing call signs?
The risk of information overload is huge, which is why the UI design here is so critical. If you present all of this telemetry at once, yes, it's totally paralyzing. But HamDash is fully modular.
Okay, meaning what?
The drag-and-drop customization allows you, the user, to tame the chaos. You can literally build your own command center.
Oh, that's brilliant.
Exactly that. You can drag the SOTA panel to the top if you only care about chasing mountain summits today, and push the shortwave broadcasts to the bottom.
Just hide what you don't need.
Right. You can filter the live cluster by specific bands, so you only see who is active on 20 meters. Or, if you're running on an older tablet out in the field and it's still too much processing power, you can switch on light mode to strip away the heavy visual elements.
Wow, so it replaces what used to be a massive physical burden. Historically, a serious operator had a desk covered in physical reference books, paper maps, a separate clock for UTC time.
Oh yeah, the shack walls were just covered in paper.
Right, and maybe 5 different browser tabs open to track solar weather, DX clusters, and satellite passes. HamDash replaces all of that. It turns a chaotic, scattered hobby into a highly organized, single-pane mission.
But we have to remember, unlike a video game, these operators are out in the actual physical world.
That is a very good point.
And when you are dealing with radio equipment in the wild, the environment isn't just a fun backdrop for your dashboard. It can be a massive, immediate hazard.
Which brings us to the safety integration, which honestly might be the most vital part of version 2.0. Think about it. If you're doing a Summits on the Air activation, you are basically hiking into the wilderness, climbing to the highest point around, building a giant metal lightning rod, and then holding onto the other end of it with your bare hands.
It sounds crazy when you say it like that, but yeah.
Having live weather integrated into your radio dashboard isn't a luxury. It's a literal survival tool.
The integration of the weather safety panel goes far beyond just telling you if it's going to rain too. It pulls from multiple high reliability sources.
Like what?
Well, it aggregates Met Office warnings, which are currently showing an all clear for the UK and Europe today, along with National Weather Service severe weather alerts in the US. It gives you 3 different radar views: NOAA, Rain Viewer, and the Met Office.
And crucially, there is a live Blitzertongue lightning detection map built right in.
That specific integration is life-saving. Blitzertung is a crowdsourced, time-of-arrival lightning detection network.
So it's real time.
Exactly. It shows you the exact age and location of lightning strikes in real time. Because if you are on a summit and you wait until you actually hear thunder to disconnect your coax cable from your radio, you are already in the danger zone.
It's too late.
Way too late. You need to see those storm cells moving in 10 miles out.
And the dashboard reinforces this physical, tangible reality with its operator toolkit. It has wire antenna length calculators and coax loss calculators.
Right, because you are dealing with real physics.
You aren't just logging into a server somewhere typing messages. You are out there cutting physical copper wire to specific mathematical lengths to perfectly match the frequency you want to bounce off the ionosphere.
And building on that physical reality, we have to look at the emergency preparedness aspect. The dashboard integrates directly with emergency networks like Skywarn in the US and RayNet in the UK.
Right, for when the corporate safety net we talked about at the beginning completely fails.
That's the pivot point. During severe weather, cell towers go down. The fiber optic cables that route our internet traffic get severed by floods, winds, or power grid failures.
It happens all the time.
In an instant, ham radio transitions from a leisurely hobby of tracking propagation and chasing remote islands to a vital, life-saving utility.
Because these operators are completely self-sufficient.
They already have their independent power sources like batteries and solar panels. They have their antennas deployed.
And the know-how.
Exactly. They have the deep technical knowledge of how to read the D layer and bounce signals off the atmosphere when local repeaters are dead. In those moments, the people using this dashboard become the only reliable line of communication for emergency services and isolated communities.
It really puts the whole ecosystem into perspective. So let's recap this journey we've been on today.
Let's do it.
We started with a rebellious, privacy-first web architecture that refuses to harvest your data, keeping everything local to your device. We use that secure foundation to look up at solar flares, tracking the SFI and K index to read the invisible mirror of the ionosphere.
A perfectly still mirror today.
Exactly. Then we zoomed in on a global network of human operators hauling generators to remote islands and mountain peaks, bouncing signals to each other, and we grounded it all in the physical, tangible reality of severe weather radars, cutting copper wire, and emergency safety networks.
It is a remarkable synthesis. You are looking at nature, human ingenuity, and a global community all operating on a single unified pane of glass.
It really is. And to you, listening to this deep dive right now, consider how easily you take modern communication for granted.
We all do it.
We do. You simply tap a smooth glass screen to send a text or load a video, and you probably never think about the massive, fragile corporate infrastructure required to make that happen. You don't think about the server farms or the undersea cables.
No one does until it breaks.
Right. But out there right now, parallel to all of that, is a completely independent network of communication.
A network that doesn't care if the internet goes down because it relies entirely on the sun, the atmosphere, and human operators braving the elements.
So I'll leave you with this final thought to mull over today. The next time you walk outside and look up at a seemingly empty blue sky, remember that it isn't empty at all.
Not even close.
It is actually teeming with an invisible, chaotic web of human connection. Thousands of people are currently bouncing voices and digital signals right over your head. Their success entirely dictated by silent solar winds and the magnetic field of the Earth. It makes you wonder, what other invisible ecosystems and networks are you walking through every single day without even realizing they exist?